Okay, here we are at 1.5, video C, talking about finding the lowest common multiple. And to find the lowest common multiple, we're going to use the idea of factors and products. So here's a factor. Remember, factors multiply together to get a product. We can also say that, let's see, here's rules for division. We've seen this before, and we can use, let's see, if we're going to find prime factorization, that's going to be helpful. We have to prime factor numbers in order to find the lowest common multiple. So prime factorization uses the cake method in the previous, described in the previous method or the previous video. So let's go and try and find, or let's go and find the lowest common multiple. Today is going to talk about the lowest common multiple. So if we're talking about the lowest common multiple, we want to know between two numbers, what's the smallest number that is a multiple of both of those numbers? Or if we've got two numbers, both of those numbers. If we've got three or more, all of the numbers that were listed. So here's an example. 24 is the lowest common multiple of 6 and 8 because 24 is divisible evenly by both 6 and 8. 6 times 4 is 24, so 8 times 3 is 24. Sure enough, those are the lowest common multiples. But how do we get there? Sometimes it jumps out at us, sometimes it doesn't. If it doesn't, especially with larger numbers, we have to use a method. So here's how to find the lowest common multiple of several numbers, two or more numbers. Number one, we've got to we have to plug in my battery. Number one, in order to find the lowest common multiple, we've got a number one prime factor each number. We did that before, prime factor by using, I like the cake method. If you don't like the cake method, you can certainly prime factor other ways. Number two, lowest common multiple includes every prime factor from every number raised to the highest power that it's seen in any number. So let's take a look at what that means. Let's go down here and prime factor 6, for example, and prime factor 8, because we had our example up here of 6 and 8, and we found that the lowest common multiple was 24. Alright, so let's prime factor 6. We could use the cake method, but you know what? It's easy enough to just list the prime factors. 2 times 3 gives me 6. There's nothing else in there. 2 is prime, 3 is prime, so there's my prime factorization. If we look at 8, we can use the cake method as well. We can also use this kind of tree method. Say 8 is 2 times 4, 4 is 2 times 2, and my prime factorization should be 2 cubed. Because I've got 2 times 2 times 2, it's 2 cubed. And that's the reason here why we use cubed. We can also use, for example, I suppose, go back to the, hang on a second. That looks better. Go back to the cake method and say if I've got green, I'm going to go to the cake method, say I'm going to use 8. First layer of the cake is, well, let's see, 2. 2 goes into 8, yep, 4 is left over. 8 divided by 2 is 4. 4 divided by 2 gives me 2. 2 down here is prime, so I'm pretty much done. 2 times 2 times 2 is my factorization, just like I found over here. 2 times 2 times 2, but it's also 2 cubed. So there's our prime factorization of 8. All right, now let's do the lowest common multiple. Lowest common multiple, I said, let's see, we've got a prime factor each number. Done. Here's my prime factorization. Here's my prime factorization. Lowest common multiple includes, then, every prime factor from every number. All right, go through the prime factors over here. 6 needs to have a 2, needs to have a 3, because we list all the prime factors here. Go over here and list the prime factors from 8. Well, it's 2. That's the only prime factor that's there, but it's listed there. So all we do in step 2a, I suppose, is just list all those prime factors. All right, so step 2b, raise those factors to the highest power seen in any number. So 2 is to the first power. All right, the 6 needs just one of these 2's. 6 needs also just one of these 3's. 8 has a 2, but it needs 3 of these 2's to be happy. So we raise the 2 factor to the third power because 8 needs 3 of them. So my lowest common multiple includes all the factors in the red from every single factor, or every single number that we've got over here. And then the blue part tells us we've got to raise it to the highest power. Raise each of these factors to the highest power seen in any one of these factorizations. That makes sure that every single factor is listed and to the highest power that we've got. So here's my 2 cubed times 3. 2 cubed is 8 times 3 equals 24, and sure enough, there's our lowest common multiple of 6 and 8. It seems straightforward with 6 and 8, and geez, why do you need to do all this stuff for 6 and 8? But that's just an example. So if we've got larger numbers like 10 and 12, so we don't want to do too much work in any kind of situation. So we're going to look for always making our life easy. Here's our steps that we had before. Find the lowest common multiple of 10 and 12. All right, well, here's 10. 10, we can use the cake method. We could say, you know what, what's in there? We'll divide out the 2 first. We got a 5, or we can just use the tree method. For 12, you know what, we might want to use because 12 is pretty big, we might want to just use the cake method just to make sure that we've got all of our stuff correct. 12, make a layer of cake. Divided by 2, yep, 12 is divisible by 2 because 2 is even. So what do we have left? 6. Take out another 2 because 6 is even. And we have just left 3, so we've got 2 times 2 times 3, or 2 squared times 3, and that's my factorization for 12. All right, lowest common multiple includes every single factor from every single product raised to the highest power. Every single factor, just list them. I got a 2. I got a 5 from the 10. From the 12, I have a 2. Well, it's listed there already. We don't have to list it again. I have to have a 3. All right, we'll list it there because it's not listed. And now we've listed all of our factors. Now raise them to the highest power that they're seen. 2 has to be to the first. 5 has to be to the first. 10 is happy if there's just one of these over here. But the 12 says he's got to have 2 of these 2's. So raise it to the highest power that you see it. Has to have a squared term because the 12 has to have 2 of those 2's in there. There's our lowest common multiple. 2 squared times 5 times 3. 4 times 5, times 3, 60 times 3, 100 and, 20 times 3, yikes, 20 times 3, 60. I'm jumping ahead of myself. 20 times 3 is 60 is our lowest common multiple. We could have said that a common multiple between 10 and 12 is 120, but if we say 120, that is a common multiple, but not a lowest common multiple. The lowest common multiple is here, 60. If we use 120 as our lowest common multiple, that means that we're actually doing extra work to convert things later on. So try to find the lowest common multiple of those two numbers. There's 3 numbers here, and you know what? On the next page, I've spread it out a little bit more. So I've got 8 and 14 and 18. I'm going to challenge you to say, you know what? Pause the video now and see if you can get the number 1, the prime factorization. We'll go back here and remember here's our prime factorization. Got a prime factor, and then lowest common multiple includes every prime factor from every number raised to the highest power seen. So see if you can do that yourself. All right, let's go here. As long as you've paused it here, we'll go through here and we'll say, what's my prime factorization of 8? 8, well, let's say we used 8, cake method, take out a 2, we got 4 left over. Cake method, take out a 2, we got 2 left over. I've got 2 cubed. Sounds good. Now on a prime factor 14, well, you know what? We know that's 2 times 7. 7's a prime. We got 2. There's my prime factorization of 14. Let's go here and say prime factorization of 18. All right, 18, you know what? It's 3 times 6, but you know what? Let's just use the cake method because it's pretty straightforward. 2 goes into 18. 9's left over. I got 9. It's not divisible by 2. It is divisible by 3. I got a 3 left over. So I got 2 times 3 squared is my prime factorization. So there are my 3 prime factorizations of 8 in blue. Prime factorization of 14 is 2 times 7. Prime factorization of 18. So let's go to red and list all of our factors. So lowest common multiple includes every single factor. From the blue, we got to have a 2. From the green, we got to have a 2. Listed there already. From the green, we got to have a 7. Listed. From the black, 18, we got to have a 2. It's there already. We got to have a 3. All right, listed there. I got 2 times 7 times 3. Those are my prime factors, but now I've got to raise them to the highest power that they're seen in any one, in any factor, in any of the 2 of 8 and 14 and 18. 2's got to be, according to 14, 14's happy if we've got 2 and 7 to the first power, so we don't. That's not the highest power. Over here, 2 to the first power. Black 18 needs 2 to the first power. Over here in blue, blue 8 needs 2 to the third power. That's the highest power that we've got to have, so we put 2 to the third power. There's a 7 here, and that's the only 7 that's listed. It's got to be to the first power. There's a 3 here. 3 is squared here. 3 has to be squared because 18 needs 2 of them. So there's our prime factorization, or sorry, lowest common multiple of 8 and 14 and 18. 2 cubed times 7 times 3 squared. 8 times 7 times 9. Won't try to do it in my head. 8 times 7 times 9, too big for me. 504 is our lowest common multiple. If you got either that circled in red or that circled in red, I'd take either one of them.